Hello everyone. So today we'll be solving one of the problem in our array series, and this is called finding the minimum in a sorted or shifted or rotated array. So what it's saying is that we have an array which is sorted but it's shifted in the sense the first element might not be the smallest one and the rightmost element should not be the larger one. So for example, in this array, if you say it started from 3 to 5 and again it starts from 1 to 2, so it's shifted in this position. So what happened is it's like definitely we can find the OFN by tracking the minimum and then traversing, or sorry, iterating from the 0th index to the last index and comparing that every number to with the minimum. But the question says to calculate the solution in like OF log n time. So iteration 1 would become like OFN, and now we have to solve it in OF log n. So this can be solved using binary search. The one thing is, like in binary search, we have a particular sorted array, so we need only two pointer from we have to need like mid pointer and left and right pointer, and move the pointer based on the values, right? But here we want to search the minimum and the array is shifted, so definitely we can create definitely we need three pointer here, like one is the left, one is right, and one is mid. But again we have to find out whether we have to search in the right side sorted array or left side sorted array by comparing the mid value. And every time we find and anytime we got a situation where the leftmost element is smaller than the rightmost element, then we we find the solution and we can return it. So let's do that. So first of all we have to create our pointers. Let's first create a result variable to hold our result, that is math. Let's initiate with using like our first value of the array. Then we're going to create our pointers, like left equals to 0th index. Then we're going to create our right pointer, that is the rightmost index, that is nums.len length -1. Then we're going to create the while loop, and we're going to run the loop until like your left is less than right. The first condition is if our leftmost element is smaller than the rightmost element, the nums of left is smaller than nums dot right. And in this particular case we're going to calculate our mean equals to math mean and then result and nums dot left, and we're going to break the loop. Then we're going to calculate the mid. Let the mid equals to math dot for right left plus right by divided by 2. And here also with this one with the mid calculated, we're gonna recalculate the result again. The result is equal to math dot mean like result and nums. So now here first we're gonna calculate if the mid, for example in this array, if mid is at 5, we're gonna see if the mid is greater than the left element. It means we don't have to search it in the right side, so we're gonna shift our left index to 1, that is mid plus 1. So we only gonna search in the right side. Same way, if the mid is less than the right left side, then we're gonna move our right index pointer to the mid -1, so that we can only search in the left side of the array. So let's implement that logic. So if nums dot mid equals to greater than nums dot left, it means we're gonna shift our left pointer equals to mid plus 1. If not, else we're gonna shift the pointer to left side, that is right pointer equals to mid -1, and at the end we gonna return our result. So this should solve our problem, and it should return the minimum value of the particular array. So let's run these test cases. So what is the issue? Math, oh sorry, the syntax issue. Where I wrote math, math.flow, sorry, this should be capital letter. So let's run it again. So all of our test cases have passed, and thanks.